when you collect data, it's always a good idea to show a visual display of what that data may look like. A stem and leaf plot is one method or one display we can use to display data. Okay, so you collect data, so you just have a list of numbers and you want to display the data in order so it makes sense. Okay, so I give you an example of race running time in seconds, and we see a stem column and a leaf column. The stems have 12, 13, and so on, and the leaves have 2, 6, 0, 2, 5, and so on. Notice at the bottom, there's a key. And you should always include a key on a stem and leaf plot because you need to be able to interpret what these stems and leaves means. Okay, so the 14/2, they're telling you that means 14.2 seconds. So in the stem column where you see 14, they're saying that's 14 seconds, and then the /2 is telling you 0.2. Okay, so that's 14.2 seconds. If you look at 16/1, that would be 16.1 seconds. The highest number, 18/3, would be 18.3 seconds. Okay, so the data values here go from 12.2 seconds as the lowest value to 18.3 as the highest value. Okay, now I mentioned stem and leaf may not always be the most appropriate display to use. Here, when you're going from about 12 to 18 seconds, that's not a huge range in your data set. But let's just suppose they went from 12.2 seconds all the way to like 30 seconds. Then you would have to have 18 different stems because you're going from 12 to 30. Okay, and that will be a very long or very large stem and leaf plot. Not that you couldn't do it, but it may not be the best display to use. Okay, there's other displays that may be appropriate. Okay, so I just want to give you an idea of how you would actually create a stem and leaf. If you were given several data values and then you had to arrange them into a stem and leaf. So let's just suppose, I wrote down several numbers here that are actually in the data set. So let's suppose you were timing people in a race and you had 13.0, 15.3, 17.8, and so on. Well, when you just look at that list of data, it's not in order, and you want to put it in order, or you want to display it so you can make some sense out of it. Okay, so what you do is you look at the lowest and the highest data values. Okay, and again, I already mentioned that 12.2 was the lowest and 18.3 was the highest. Now, they may not both show up in the list I wrote out, but the point is still there, that you would find the highest and lowest data value to determine if a stem and leaf is appropriate or not. Okay, and that's a fairly small range of values, so a stem and leaf would make sense here. Okay, so what you do is you would list the whole number of seconds, 12, 13, 14, and so on, all the way up to 18. And then, when you organize them in the list, notice how the leaves column, you have 2, 6, 0, 2, 5, and so on. Notice you start with the smallest leaf value and work your way up in each of the rows. So 12 point something. Well, notice it's 2, then 6. You always arrange them from smallest to lowest in the leaves. Okay, so as you go through your data set, what I would suggest you do is you look at your lowest data value, which is 12.2, and then work off of that. Are there any other 12s? And you can go through and like make little tick marks or make a little note or maybe put an X through ones that you've already used. So by the time you get to, say, 13.0, well, the 0 is the first number there because that's 13.0 is going to be the smallest in that row. So put a little check mark or put a line through it, whatever you do so you know you've used that one. And then go through the rest of your data. And again, if there's a huge data set, a stem and leaf will be very difficult by hand to do. So it may not be the most appropriate choice. But you go through the other 13s. Well, here's the 13.5. We know somewhere there's a 13.2. So you would find all your 13s. If you want, again, if you want to put a little check mark next to them and then organize them, okay, that's up to you. Okay, whatever you find easiest. But I suggest you put a little line through them once you actually write them in your table. right in your stem and leaf plot. So then you don't have to look at them again. Okay, and then you go to 14, see if there's any in there, and then 15, and do the same process throughout. Okay, the next example of a stem and leaf is what we call a back-to-back stem and leaf. And this represents a little survey that was given asking the number of movies watched in the past year. Okay, the results are given in this stem and leaf plot for males and females. Okay, so you notice if you look at just the right-hand part, you have 1, 2, 3, 4, 5, 6, 7. So that represents, looking at the key, 1/5, meaning 15. So that very first row there, 1/5, meaning 15. So there is a female who watched 15 movies in the last year. Another female watched 18 movies. Another female watched 21. Two females watched 29 movies. Okay, and some female watched 72 movies. I think they need to get out more. Okay, so, and then on the other side, back-to-back stem and leaf, you also have the males. And this is very common to use the back-to-back stem and leaf when you have more than one category, like males and females, and you want to display them back-to-back to kind of see how the two distributions may compare. Okay, so 1, 0, so there's a male that watched 10, 1, 2, there is a male that watched 12, and so on. Okay, so that's when I just wanted to explain of how you look at that and read that, because it's sometimes hard to tell exactly what that's telling us. Okay, if you're just given that without being any kind of explanation. Okay, and then on the next page, just a few more different types of examples. Again, not to go too crazy with these, but just to show you some different ways that stem and leaves can show up and how the stems and leaves may appear. Okay, so here we have winning times for bobsled teams at the 2010 Winter Olympics. So here looking at the key, so 3:26/65 means 3 minutes and 26 seconds. And then the 65 represents the 0.65. Okay, so that's just another example. In this one, notice the leaves are 2 digits long, okay, which is okay. Sometimes you'll see commas separate them, like in the last example. Okay, it just depends on the person making it. Okay, and then the last one, and I should point out in this one too, is that when you do a stem and leaf, you shouldn't skip stems, because part of the idea is you want to see how the data is spread out and what the data set looks like and how close the data values are to each other. So even though there was no one that had 3 minutes 31 point anything, okay, you still put that 3:31 in there. You don't skip over it and then put the 3:32. Okay, you actually enter the 3:31, so you can see there was nobody in there. Okay, and that allows you to see that 3:32.06 seconds, that was a little farther away than it might appear if that 3:31 isn't even there, because you might not really recognize that there's a difference there, and you don't want to make the 3:32 time look like it's closer to the others. Okay, so just be careful of things like that. Okay, then the last one, this is similar to the first one, giving body temperature for 65 healthy adult women. And you have the key down here, 96/4, meaning 96.4 degrees. Okay, what I point out on this one is when you're looking at all those values in there, okay, I could ask you what the median is, what the mode is. Okay, so which one occurs most often, where the middle number is, the percentiles, and we'll do that in a later lesson. Okay, but you can see that in this one you have several numbers showing up more than once. Okay, which just means that that there were several different women that had those temperatures. Okay, so the 65 adult women, you should be able to count the number of leaves. So the 4, 7, 8, and so on. If you count those, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, keep on counting, you should get to 65. Okay, so that's how you can tell how many people are in the data set, by counting the leave unit.